Chapter 8 focuses on the concepts that you'll use in order to design a system, and I know that you aren't going to be necessarily creating systems, but you'll be working with the developers who will be developing the systems for you. So it's a good idea for you to know how you can help them best build the system that you need to accomplish the task you need to perform. So a system view is basically looking at the framework of what's involved, what you want to accomplish, and the inputs and outputs and the boundaries of the system. And an information system not only includes the hardware and the software, but it also includes the people and the procedures. So you have a lot more to an information system than just the technology itself. It's the people who use it. So it's important for you to be involved in the process of developing what you need in regards to technology. A systems perspective is keeping in mind that each system is made up of subsystems that all must work together and share data. So in this particular picture we see an example of a system made up of small subsystems. The individual subsystems work. Here the door works, and this chimney we can see it works, and that guy's actually taking a bath. But if they aren't put together appropriately, then you have a very poorly designed system. So you want to make sure your design is correct. Even if the subsystems work, if they aren't put together correctly, then you're going to have a problem. So these are the elements of a system, and we're going to take a look at each one of these in the next few slides. So a boundary defines what is within the system and what's outside the system. Basically it separates the system from its environment, and we can see it defines the scope of the system, and everything in the environment is outside. It's something that we can't control. Now inputs are resources that are used within our system to generate an output that is sent out to the environment. Inputs usually come from outside the environment in. However, there may be some inputs generated within our system itself, and the components are the individual activities within our system that turn the inputs into outputs, and there may be subsystems inside our system. The interface is where our components meet, or where our component meets the environment. It's a means of maybe a user interface, something that allows us to transfer the data between the two devices. And storage may take place inside our system for temporary or permanent use of data for the resource that we use inside of our system. Now you can see some examples of each one of those different elements. I want to take a look down here at interfaces, and for instance in a payroll system, the interface here, we're matching time cards to employees. We're preparing the data and making sure that it's correct and preparing it for our system. So here's an example of decomposition where we have a sales summary system over here on the left hand side, and it has two components or two subsystems, the verify customer orders and produce sales summaries. And then over here on the right hand side we have a more detailed look at the produce sales summary. So this is what's going on inside this box. So we see here's the boundary of the system that separates the environment from the system itself. We see the inputs that are coming in, as well as some outputs that come out from this particular part of the system. So customer orders and product lists, that goes into the process for verifying the customer orders, and we have to verify that the customer order is requesting items on our product list, and if there is a valid request, then we'll send that on to the next step in the process. But if not, we reject the order and send it back to the customer. Now in this part of the process we have two inputs, valid customer orders and sales history. So now that this area over here is a breakdown of this process here, let's take a look at the sub-processes that take place inside this box. So we have two items that are coming in, two inputs, the valid customer orders, here it is, and the sales history, here it is. Now we see there's one output coming out, sales summaries. Well, we have sales summaries listed over here. We have two types of sales summaries, the monthly dollar sales summary, and we also have this product sales comparison. So that's a summary of product sales. So inside that box we have these individual subsystems taking place, and data being transferred between the elements or between those subsystems inside the product sales summary. So key design concepts to keep in mind: you need to choose an appropriate scope, something that's not too big but not too small, that limits what you're trying to get accomplished, but you don't want scope creep where your system keeps getting bigger and bigger. So you do want to define a scope. You also need to know what you want your system to accomplish before you ever start thinking about the types of databases or technology you're going to use to create the system. Now, this hierarchical decomposition is kind of what we saw in the previous two slides, where you break the problem down into smaller, more manageable functions or processes. So you take a big process and you break it down into smaller processes or smaller subsystems that you can work with. You try to separate those so they're individual, completely unique, independent components, so that if something goes wrong with one, it doesn't affect the entire system. And this allows different people to be able to work on the system at the same time, because you have people designated to work on the subsystems, and they can do them in parallel. Another step in the process is looking at different alternatives and evaluating those alternatives to come up with a final solution. And then once you've decided upon a solution, taking that solution in steps so that you can get this project created in a more manageable fashion. And things may change as you go along, so you want to be able to incorporate those changes into the design process. Now, we saw this figure earlier. This is the Levitt model, and this is a great tool to use in order to evaluate a system and the elements of the system, where we see that each one interacts, and if you change one, you're going to wind up having to adjust the others as well. That's a good tool to use to look at a process that you're trying to change and trying to define the different elements that fit that process. In the business process approach, you take a look at the entire process. You want to look at all the activities that are performed. And when you do business process reengineering, you're trying to basically kind of start from a clean slate. You want to kind of clear your mind of the way things have been taking place, so that you can come up with new out-of-the-box ways of thinking in order to move your organization on and improve the process that you're trying to redesign or re-engineer. And this figure gives you some ideas of some principles you need to follow as you try to redesign a process. If you take a look at the first one, it says organized business processes around outcomes, not tasks. So what you want to get accomplished from that individual or from that one system, and then that will help you think about, okay, this is what we want to accomplish. What can we do in order to get that task accomplished or get that project accomplished? Now, the information systems life cycle consists of three main steps, and in the next chapter we're going to break those three main steps down even further. And in the definition phase, we're basically trying to talk to end users. Our end users and our computer analysts or our business analysts work together in order to define what it is that we need. And maybe it's something that we already have, the business people just aren't aware of it. So you're trying to define the problem, define the need before you ever go into the process of actually trying to start thinking about building the system. And that step comes into construction, where you actually go through a very structured process in order to develop a system. If you take a look at the elements involved, it says you design, build, and test a system. So here within this process, you design it, but you also you come up with the requirements, you design it, and then you also build it and start preparing to install it, which is the next step, the implementation. And part of that, as you look down here, is getting people trained, putting in or uploading the old data. Maintaining the system is a long, ongoing process. This is probably the largest part of the entire systems development process, because it's ongoing. It's going to take place every year. We see that with our operating system upgrades and patches that get downloaded to our systems. Maintenance is just something that you continuously takes place as operating systems change and as other applications that you interact with change. So in the structured technique, we have basically three models. The as-is, which is the current way of doing something, the current process that you have in place. The logical to-be, that's the system you're going to develop. So you've looked at your as-is processes, how you are doing things, and you decide, well, yes, we do need a new technology system built. And so here you're thinking about logically how that system's going to work in your organization, what it's supposed to do, how it's going to interact with other systems and generate the data that you need. In the next step, the translate into physical to-be, this is where you're starting to think about the actual physical system and the hardware and software and all the technologies that are going to be used in order to create that system. So one of the models in the as-is process is the context diagram. Now we're taking a look at developing a system from a procedure oriented perspective. So in this context diagram, we're looking at an accounts payable process. This is the center process, and we're looking at from a top level, top of a skyscraper view. We're looking at where do the inputs come from, where do the outputs go to. We aren't concerned at this point about the individual steps inside the accounts payable process. We will be getting to that in the next models. So this is kind of taking a look at what we were looking at a while ago as we did that decomposition. I'm going to go back to it just a minute. In this figure we have a top level view of the produced sales summaries, and then we go a little bit deeper into this, and then we could go a little bit deeper into each one of these individual processes. So in this accounts payable process, we see that the data that's coming into the system is vendor invoices, and what comes out of this accounts payable process is checks and rejected invoices. And that data, the vendor invoices, is created by the vendor, and what goes to the vendor is checks for what we have purchased from them, or if we don't want the items that they are trying to sell us, we have a rejected invoice. The process of writing a check or rejecting the invoice takes place with this information that we get from accounting and also purchasing. So with purchasing, we get a purchase order, and we check the purchase order to see if it matches what we supposedly have received from the vendor on the vendor invoice. If it does, we write the check. We might also get information about products or the vendors themselves, so we can write the check. Stock receipts that say yes, these goods have been received. So matching the purchase order, the vendor invoice, and the stock receipt is a good idea to make sure that what we ordered was what the vendor's charging us for and is actually what we received. Now if we do write the check, we'll have to send a payable summary to the accounting department. If not, we will probably just write some notes about the entire process, but we will send the rejected invoice back to the vendor. Now, the next step of the process, we saw the as-is process. Now we're looking at the logical to be. We're looking at how the data flows through the entire process, and we diagram that out. We look at what entities are generating the data, where the data goes, how the different entities are related. We want to get rid of any kind of duplication that's within our system. So we're looking at the flow of data through the entire process.